Okay, here's part two. And again, I apologize for the audio quality. I'm using the built-in one on the laptop until I can get a hold of the actual webcam or desktop microphone. So bear with me, adjust the volume, use closed captions. We'll get through this week. I have a few promising leads. Anyway, so last installment we talked about points and condenser, kind of just basically turning on and off that primary circuit in the coil, which you can see right here. This is a schematic of the primary side. Goes to the battery, the ignition switch, comes through here. Magnetic field builds around this part. This goes through the ground, and then it went to what once was those points. Well, this changes. Now we have a transistor here. So it's an electronic version of those points. Those points can also be called a switch, and that's what this is, an electronic switch, kind of a relay switch thing. So what happens as this reluctor, this magnetic wheel goes around, here it goes clockwise. It's got a north and a south, these little magnets. It's going to vary and induce the current in this coil. That's going to come through, signal this base, and when that base right there gets signaled, this ground path right here gets connected through this transistor to ground right here. And then as this, I said, moves around right here, it's going to change that signal, which opens and closes that base, much like that cam did on the electric points, or the points and condenser. So this reluctor and this transistor just basically replace that block and points that lift up and down and close an actual breaker. Everything else is the same. Just now you have no wear item. Remember I kept talking about arcing that breaker point and wearing it down? Well, now it's all done electronically, again, through this reluctor, this coil, signal on this base, which either allows current to go through or does not. We still have that condenser capacitor here to help prolong the life and protect this transistor from a spike, a voltage spike. Because what happens when this opens and closes, that magnetic field collapses. It's going to spike not only through the secondary, but through back through that primary. So that will protect it. So let's move on from there. And then here's another picture. And we got right here 1, 2, 3, 4, 5, 6, 7, 8. Here's an 8-cylinder. Here's your magnetic pickup, that reluctor right here. And then basically the same kind of setup we're looking inside here as the points and condenser. After that, we went to this distributorless ignition system. So this distributor is gone. We have, like, this is a 6-cylinder. You can see 1, 2, 3, 4, 6, 5. We'll talk about that later. That's how fire and order works. This actually is 3 ignition coils, much like I just showed you before with that can coil. 4 and 3 are connected. 6 and 2 are connected. 5 and 1 are connected. So they're actually one coil here, a coil here, and a coil here. And you notice we have 1, 2, 3, 4 wires. Okay, because we're going to have 3 ground signals and a hot from the battery. So power comes in, it goes into the coil, and it powers these 3 coils. And then each 3 of them is grounded individually by the computer, which will fire the secondary spark out of one of these towers, and it's going to loop through. So this is called a waste spark system. What's going to happen is it'll come out of, let's say, this tower 1. It'll go through cylinder 1, but it's going to go through the block, up cylinder 5, and backwards to complete that loop into this coil here. And then when cylinder 5 needs it, it'll fire again. So it fires on the compression, it's going into the compression to power, and then also on the exhaust. So it's kind of a waste spark system, or a loop spark, they call it. Distributorless ignition. Here is a schematic of that, what I was just talking about. So as it comes through, this is like a coil pack right here, 1 and 5, 2 and 6, and 3 and 4. So here you go, secondary, or primary, excuse me, and then here's your secondary. So that's what this is right here. This is representing that secondary right here. One end's connected to cylinder 1, the other end's connected to cylinder 5. So if it fires, it's going to loop around both those. One's going to come out the center electrode to the ground. It'll go through the ground on the other one, back to the center, and then loop back through to that coil right there. Okay, and that's basically, I said, a waste spark system, distributorless. After this, they went on to a coil on plug. So each spark plug got its own ignition coil individually. That way the computer can control very accurately, basically just more control of dwell, saturation, when it's going to spark, advanced, stuff like that. And here is a single electrode spark plug. This one looks like it's a nickel. Inside is copper and then nickel plated. There's your center electrode, or right here is your ground electrode, threaded right through here. Here's your crush little washer right here for a compression seal. You want these to be new. When you put them on, these threads will be cleaned, and pretty much all these spark plugs, you're going to want to put a little anti-seize in here. The only ones I didn't put that on is like a Ford 5.4 3-valve Triton, just because you'll see them, they don't have many threads. There's just a little bit of threads there. That was my opinion. Ask 2 techs, you get 2 answers. But yeah, a little anti-seize inside these threads, and then you want to torque them to spec. Don't guess. These do need to be torqued and sealed correctly. You can't have problems on some exotic cars and even domestic cars. So if you're inspecting these for, like, let's say a misfire, you're going to look for cracks on this porcelain if you think you have one of these misfiring. Or down here, this electrode, this can be slammed shut. It can be different colors. Inside your textbook, or Electude, sorry, it'll show you some of those common visuals of that. There'll be a picture at the end of this slide as well. But you're looking for a nice light brown color. Nothing's too close, too big in this gap. Nothing built up. You don't want any oil coked up in here. You don't want it wet with fuel. You're looking for stuff like that. Sign of water, rust, etc. But this is your classic single electrode spark plug, copper with nickel plating. Here's a fancy dual electrode. And the caveat here are people think that it's going to have 2 sparks. That's not the way electricity works. It's going to probably go through one right here until that wears or has corrosion. Then it'll go through the other one until that wears, and it'll kind of bounce back and forth. Other than that, pretty much the same when you're inspecting them. Here's a 4 electrode, real popular. This little like Bosch center electrode looking piece right here. Here's that crush washer right there. Again, your threads, want to make sure they're clean. Nothing's discolored, nothing's built up, no carbon, no fuel, etc. And wow, what's this? Look right here, you got a Motorcraft part number going on right here. Yep, this is out of a Ford 5.4. This one is a 3-valve 5.4. So basically what happened is these center electrode, this section right here is a wrapped around ground electrode. There's your center electrode, and that's going to go down into the cylinder and down the combustion chamber, just the design of the head. Typically what happens here is a lot of carbon gets built up right here, and then when you're taking these plugs out, it snaps right in this area. And this part down here stays in the head, and this part right here comes out. And you have to have a special tool to remove this inner part. Here's a used one over here. It'll start, see that carbon? It'll start building up in here and start getting down into this base up in here. And then here's another, just look at a copper core spark plug, the inside. Here's platinum. So basically you have your copper core, it's nickel, then it has this platinum disc for wear, a single platinum or double platinum, where it has platinum on both sides. That's a harder metal to just prolong wear so it lasts a bit longer. And the next step up from there is iridium. It's going to have iridium inside here. There it is right there. Nice sharp point, little hard metal guy right there. And again, if you're going to be having platinum and up spark plugs, you can check the gap, but you shouldn't have to adjust it. Be very careful. That hard metal can crack if you're adjusting or bending or moving around. So spark plugs also come in what's called a different heat range. So basically you have a hot spark plug. If you take a look at this porcelain right here, and then compare to the cold spark plug with much more porcelain right here. This is how much does it transfer heat from the combustion chamber up through the spark plug into the head and the coolant. If it transfers the heat very fast right here, you're going to have this cold, and slower, you have this hot one. So right here, shorter path, faster heat is dissipated. Longer path, slower the heat dissipated. Basically, it depends on how you're driving your car. Short trip, stop and go. Long insulator, you want higher heat. If you're going to be driving it heavy loads, high speed, you can do a colder plug. Again, my advice is to go with what's OE, original equipment. And then I also used a brand that came in that engine. So if you're running a Ford engine, Motorcraft, if it's a GM product, AC Delco, Daimler, Chrysler, Jeep, if you're looking at Champion, your Japanese products, NGK, Nippon Denso stuff, German, it's Bosch, but I still like to use NGK on a European vehicle as well. The thing is, if you go to the parts department and say, hey, I need a spark plug for this car, they're going to give you an array of brands. Now, just because a brand fits doesn't mean that the spark plug is clocked correctly, which means where this ground electrode is facing in the combustion chamber. It also doesn't mean that the heat range is correct. It just means that it physically fits. So you may or may not want to just change brands. I would stick with what came with the vehicle unless you really want to dial in and you know what you're doing with heat ranges and brands and clocking. And so stick with OE, and you'll be fine. So here's what I was mentioning earlier: some diagnosing those spark plugs. So here's carbon deposit. Pretty. I would say normal, but I've seen this. This is the ashy or the brown color. Too much ash buildup right here. You got some type of deposits, additive. Oil. You got something leaking, valve guides, oil leak. Too hot. You'll see it starts getting fatigued, thin, like it's burning. This is just worn out. Big gap right here. Detonation. You start seeing almost like somebody with a hammer. Some marks, some damage to it. Pre-ignition. Too hot. Basically, it's igniting before. And then you have glazing, splash deposits, mechanical damage, something's hitting it, and then gap bridging where it's touching right here. So there's spark plugs. Again, take a look here. Kind of a normally worn one, severely worn. Look at the spark plug gap. Some coils cannot gap that. That's why you have to check the gap, make sure that that is set to factory adjustments. So we talked about physical timing when we talked about camshafts, overhead valve, overhead cam. There's also ignition timing. So ignition timing is when that spark is introduced into the combustion chamber. On a distributor engine, that can be adjusted by turning the distributor. And what that does, if you remember the picture before, if you turn the distributor, you're changing at what point those points open and closed on that 360-degree rotation. So if you want to advance it or retard it, you're going to change that, turn that distributor clockwise or counterclockwise. And the way we check that is with a timing light. So we hook this up to the car battery. This pickup right here goes into cylinder number 1 spark plug wire. And what happens when the current comes through the spark plug wire, it's going to signal this pickup, and that comes this light. The light will flash a strobe light only when there's a signal coming through this pickup. So if you point this light down at this crank damper right here, this harmonic balancer damper, it's going to shine the light only when that cylinder is being fired. And what the effect is a strobe effect. So it makes this damper look like it's not moving. And you'll see this little notch right here, and it looks like it's not moving, even though the vehicle's idling at 600, 700, 800 RPM. And you're going to make sure that that lines up with where it needs to be according to spec. It could be 8 degrees before top dead center. It could be here 12, somewhere in here, 4. I don't know. You got to look up the spec on your vehicle. Some lights, advanced timing lights, you can adjust the timing on the light. That way the notch just goes to 0, and you adjust forward on that gun. Okay, so check there. Let's go. Not adjustable on distributorless or coil on plug. It's not adjustable by your standard technician. It is adjustable, but that's software. So here's your reason for ignition timing. As load and RPM change, so must timing. If you take a look at this matrix, you have load and then RPM right here. So low load needs more timing, and then high load needs less timing. And then if you look at RPM, low RPM needs less timing, and of course, conversely, a high RPM needs more timing. So this is kind of your mapping matrix right here, and these are all your timing map. So a reason again for ignition timing, this is when the spark is introduced at the spark plug. As it builds that flame front, you can see how much time it takes for it to build. Here you got 70 milliseconds before you get a nice flame. And then again, you want that flame to hit the top of the piston as the piston is going down. And we talked about that when we were talking about physical timing, camshaft timing. Remember, intake, compression, power, exhaust. So you want that cylinder to be crossing over from compression to power right when this flame hits the top of that piston. If it hits it too soon, you get knocking noise, or you get pre-ignition. If the gas ignites before the spark, like from compression. So here you go, intake, compression, power, exhaust, just like before. So I think I'm going to stop this one right here, this video.